Good morning. I would like to welcome all of you to Degree Calculations 6th episode. Last time, when I was doing 5th episode, I had told you, I had given you one exercise, that is one oval shaped job. Its radius is 600 from here to here is 600. It means recognize its arrow marks from center to outside. It was 600 and its thickness is 20 mm. It is a half round. Here is also one half round we can see. In between, one straight portion is there, straight portion. Length of this straight portion I have indicated, that is 700. So this measurement I had given you last episode time. That time I didn't give you its height. Height, where will I be showing its height? It is plan, everybody knows it. If we look it from top side, we will see it. Whatever we will see it from here, when we look it from here, we will see its front view. Its front view is called elevation. It is its elevation or front view. You know about it because I have told you about it in last some episodes. I don't describe about it now. So we can see its outer surface, outer shell, that has been indicated here from here to here as a thick line. I have told you about it, those all in last episode. It is a thick line. Inside we can see one dotted line. Inside we can see one dotted line. Why it has been written by dotted line? Because when we look this job from here, when we look it from here, we can see its outer surface only. Outer surface we will see as a line. So it has been indicated as a line. But inside the wall we can see, but it is there. So we have to indicate about it as a dotted line. And its top side is round. This round, when we look from one side, it will be shown as a line. So I have indicated it as a line. Here also we can see one line. When we look this oval shaped job from front side, we can see one line. But when we look this line from the top side, it is a half round. Two half rounds are there. Okay. So last time I had told you, you have to do the pattern development. You have to draw the development of this job. Development means for making this kind of one job, we have to take one sheet or plate. Its length and width is called development. Sometimes we can't say about it is having a proper length. We can't say about it is having a proper width, because sometimes it may not have a rectangular shape or square shape. It won't have a round shape. It will have different types of shapes, like amoeba. Amoeba is not having a perfect shape. Its shape is having changes. So this development also will have changes. Next time we will be going to more congested developments. Those times you can see all developments are not coming in rectangular shape. All developments are coming in square shape or round shape or oval shape. Everything is having different types of structures, different shapes. We can see those all. So first now you study how will be its development. One straight portion is there from here to here. Afterwards there is a rolled portion. Again we can see straight portion. Again we can see rolled portion. So when we draw its pattern development, its development will be like this. It is a rectangular shaped job. First portion will be straight from here to here. It is straight. I have written here straight because this portion is straight from here to here. It is straight. So I have indicated straight portion. Afterwards, rolled portion is coming. Here I have written rolling. So first we see straight portion, then rolled portion is coming, again straight portion. So two straight portions and two rolled portions are coming. One straight portion is coming, again rolled portion is coming, again straight portion. Here it is straight portion. I have written its short form S. Straight portion. Two straight portions are coming. One is here, another one is here. Two rolled portions are coming. Here I have written rolling. Here is also a rolling area. I have written R only. So it is its development. Its height will be from here to here. It will be 2000 because its height is 2000. How I have indicated that 2000 here, but it is not the proper method of indicating measurement. Last time I had told you how will you be indicating measurements. I have told you from the original job there should be 3 mm gap. Afterwards 10 mm one line has to be written. Here also it has to be indicated 3 mm gap and 10 mm line. That should be a thin line and there will be one line. In that line we have to indicate 2000. But now I didn't indicate those all because now I am teaching only. It is for, so I made my hands sketch only. It is freehand sketch only. I didn't use a scale. I don't use scale or compass. But you have to use scale and compass and you have to write it properly. Okay. So its height is 2000 from here to here. What is the length from here to here? Straight length. It is straight area. How much it will be? You know, it has straight area from here to here is 700. So this length will be 700. From here to here it will be 700. I have indicated it here. This is the development. In this development I didn't write about its measurements. Those measurements I have indicated here. From here to here 700. That measurement I have written here 700. It is a rough sketch, but when you do its development, when you draw its development, you have to use proper scale. It should be in a scale. Okay. Its height is 2000. From here to here 2000. And what should be the next rolled area? We could write 700 in development area. What should be the measurement from here to here? For that purpose we have to find out its perimeter. What should be the perimeter? Last time I have told you the method to find out the perimeter. Its formula is pi d. Pi into d. But here is, if we find out pi d, we will get the perimeter from here to, not here, full rounds perimeter we will get. We have to divide it with 2 because it is half portion of the round. For that purpose we had invented one formula. It is pi d into degree divided by 360. Pi d into degree divided by 360. That formula we had found out last time. What is this pi? Pi is 3.14, you know. What is d? D is diameter. What is the diameter here? It shouldn't be, sometimes we may think its diameter is 600 plus 600 is 1200. But we shouldn't use the diameter 1200 because it is major diameter. And its minor diameter will be, we have to decrease 20 mm thickness from 600. Here also 600, from 600 to 20 has to be decreased. So if we decrease 1200 from here to here, it will be 1200 because from here to here is 600. Another 600 is coming from here to here. So total length is 1200. From this 1200, if we decrease 20 here and 20 here, we get minor diameter. What is this minor diameter? It will be from 1200 minus 20, again 20, it will be 1100 60. But we shouldn't use major diameter, we shouldn't use minor diameter. It's reason I have told you. What should we use? Instead of major diameter, instead of minor diameter, we have to use medium diameter. Medium diameter is the diameter which is coming from the center of thickness to the center of the thickness. Here I have indicated a dotted line. From dotted line to dotted line is medium diameter. This medium diameter won't have any change when we roll, but the major diameter will have changes. It will be increased. Minor diameter also will have changes. It will be decreased. So this medium diameter won't have changes when we bend or when we roll. So we have to use medium diameter. What is the medium diameter? From major diameter, that is 1200, we have to decrease half thickness of this area and half thickness of this area. This thickness is 20 mm. We have indicated it here. From half of this 20 mm is 10 mm. From outside to the center is dotted line is 10 mm. Here is also outside to dotted line is 10 mm. So from 1200, from here to here is 1200. From this measurement we have to decrease 110 here, another 10 here. So we have to decrease 20 mm. One full thickness has to be decreased. I have written it here. Pi d into degree divided by 360. This is called theta. Theta is indicating degree. Pi d into degree divided by 360 means pi d into degree by 360. Here I have written theta, degree, both are same. We can apply this measurements in this pi d into degree divided by 360. Why do we use the formula degree by 360? Because we don't want full perimeter. If full degree is 360, we need only 180 degree. So 180 by 360 is equal to 1 by 2. 180 by 360 becomes half of the total. We have to recognize always this degrees, how many times big is, how many times greater one is the total degree. So 180 is 2 times big is total of 360. If it is so, this half rounds 2 times it will be the total perimeter. So we have to find out how we have to recognize how many times big it is. If this degree is 2 times big, we have to use that. We have to recognize this total perimeter will become 2 times big. In another way we can say, if it is 2, this half portion will be 1. 1 part of 2, it will be 1 part of 2. In another way we can say 180 part of 360, both are same. 180 part of 360 and 1 part of 2, both are same. Last time I had told you about it, so I don't explain those all now. Okay, we can apply these measurements in pi d into degree divided by 360. Pi d into degree divided by 360. Pi is equal to 3.14. You know, d is 1180 because from 1200 we have decreased one thickness half here, one thickness half here. Total one thickness we have decreased. From major diameter we have decreased. We can say 2 ways. From major diameter we have decreased half thickness and again half thickness. 2 half thicknesses we have decreased. 2 half thicknesses means 1 full thickness. So from major diameter we have decreased 1 full thickness. So we get 1180. 1200 minus 20 is 1180. So pi d into degree is 180. This degree is 180 degree. It is half round. From here to here is half round because this straight line is coming from the tangent of this round. Tangent of this tangent is this portion. From this tangent it starts because this because of that, this round is half round. This is 180 degree. Full round is 360 degree and half round is 180 degree. So degree is 180. Pi d into 180 divided by 360. When we use this formula, we get this much of measurement. We can just check using calculator. We can use the formula pi d into degree divided by 360. Pi, instead of pi, we can touch and shift, and this is also the measurement of pi. Already pi has come. Then pi will have more accuracy because value of pi is not 3.14. It is, we can use it for our own purposes only, but it is really a valuable, more accurate measurement. It is having so many numbers after 3.14. After 3.14, so many numbers are coming. But we have taken these two numbers only. After 0.14, we are using only. So many numbers are coming. So if we use direct pi, we will get more accuracy. Okay, pi d into degree divided by 360. Pi into d is 1180. 1180 into 180. 180 is degree. 180 divided by 360. Divided by 360 is equal to, we get 1853.5. 1853.5. So what is this measurement? 1853.5. 1853.5 is the perimeter of this half round. Perimeter of half round. This measurement, if we use and if we cut a piece in this length, and it is having a thickness of 20 mm, if we roll it, we will get a measurement job which will have a major radius of 600. Okay, then recognize perimeter from here to here is 1853.5. So we got this measurement 700. We got this measurement also. We got 1853.5. This measurement also we have, it is 700. This measurement also now we have got, because both are half rounds. If it is 1853.5, this one also will be 1853.5. So we can put these all measurements in our pattern development. So in pattern development, first we have put the measurement from here to here is 700. From here to here is 1853.5, because we got the perimeter. It is the area from here to here is rolling area. Again straight area, this is 700. That is, again we get the rolled area, that is 1853.5. So 700's area, rolling area 1853.5, again straight area, that is 700, again rolled area. This is the development of this job. For making this kind of one job with the height of 2000, we have to use these measurements. Its height should be, width should be 2000, rolled area will be 1853.5 to rolled area, sir. This is also rolled area. Okay, this is 700 is straight area. So what should be the length from here to here? Total length will be, we have to add these all, 700 plus 1853.5 plus again 700 plus 1853.5. What is this measurement? It is, if we add these all together, we get 5169.9. We can check it using calculator. 700 plus 1853.5 plus 700 plus 1853.5 is equal to 5100. I got some mistake. Sorry, I got some mistake. I will rectify it. $700 plus 1,853.5. 1,853.5 plus again 700 plus 1,853.5. 1,853.5. That is 5,107. I got one mistake. I wrote here 5,169.9. That is wrong. Measurement is 5,107. Sorry, I got one mistake. 5,107. Okay. So I have to change this 5,107 here also. I have to change this measurement also, because for teaching you I made one view of this place. If we look this from here, we can see like this. From here to here is 700. Here to here is 1,853.5. Again here to here is 700. Again rolled area 1,853.5. This total length is 5,107. When I wrote it, I got one mistake again. Forgive me. 5,107. So this job's view from here is this one. Why did I write? Means I had to indicate this sharp marks. What is this bevel indicates? It is indicating welding. Those area we have to weld. After cutting, we have to bend here. We will make rolling in this area. Then it will come to like this. Again straight area comes. Again this rolled area will reach here. These two portions, this one and this one, will match together. It has to be matched together. Afterwards we have to weld it. So we have to use bevel. We can say about bevel and its degree and its gap. Those all can be told in coming episodes. Now I am not describing about it. So if we don't give gap for this one, we can directly use 5,107, but we have to use gap. So we will have to decrease 5,100 something or some gap area measurement from 5,107. Another thing, after making this one, this job will have shrinkage. It will come down because of welding. This measurement will come a smaller amount, come to a amount, its measurement will be decreased. So we have to take some more lengthy measurement, some 1, 2, 3, whatever shrinkage will happen, those will have to be increased. So those ones can be described in coming episodes. Now you just think, for making this development, it has to have a length of 5,107 length. From here to here is 5,107, and its width will be from here to here, it will be 2,000. 5,107 into 2,000 length we have to take. It is one development, but it is having a lot of goodnesses also. It is having a lot of problems also. One goodness of this job is we can make this material from this job from one material. That is one goodness. Another one goodness is we don't lose material, because if it is a big plate, from one plate we can cut and make this one. So many goodnesses are there. And we don't weld here, we don't weld here, we don't weld here. We can weld these two portions only. If we give welding, it won't have a strength like a parent metal. it won't have a strength like original metal. But so that may also be a goodness of this kind of jobs. That kind of so many goodnesses are there. We can earn time because we don't set. If it was separate pieces, we had to set. So we earn time, we don't lose material, we don't lose cutting time, we don't lose welding welding time, welding rod. That kind of so many facilities are there. 1 2 3 4 5, we can say so many facilities. But it is having some faults also. If we cut it from a full length plate, that much of plate will be lost. But if we make small pieces for this one, we can take it from scrap pieces also, small pieces also. So if we take a full plate, it is having some fault. And if it is a lengthy plate, widthy plate, big plate, it will be very difficult for us to handle. That may be also a fault of this purpose. And when we roll this one, it may have twist, it may not be reaching in the, it will be very difficult to contact this area to this area. These two areas may have some twists. It may not be reaching proper place. We will have to use wedges, we will have to use hydraulic jacks, we will have to use chain blocks, gear, that kind of lever blocks, that kind of things we have to use sometimes if it has got twist. So that kind of faults are there. So if I have written so many goodnesses for this one, it is having some faults also. So some companies will have more material, some companies will have more quality machines, some companies will have good platforms, so many facilities will be there. Some other companies won't have this much of good machines, this much of material won't be there, this much of good platforms may not be there, this much of facilities, crane facility and some other facilities may not have there. So always we shouldn't take development in this way. We have to recognize the practical faults of our own company, our own engineering workshop, and we have to take its development. So it is one development only. 2-3 developments are also we can make. One development is take this kind of one plate in this rectangular shape, means one straight area. I have indicated it here. This straight area is 700 width and 2000 length. That kind of two jobs have to be made. I have indicated it here, 700 into 2000. If we take this kind of two jobs, actually this whiteboard doesn't have more place, so when I drew this one, I made a small drawing because there is enough place. So if you make one 700 into 2000's, two places, one is for this place, one is for this place, this area. This drawing, this 700 into 2000 area I have drawn here, but it doesn't have more length width because there is enough place. So it is also a 700 into 2000. It is also a development, but this kind of two numbers have to be made. For one is for this place and another one is for this place. And we have to give bevel, we have to do all setting works, all welding works we have to do here also. So we have to take two plates like this, we have to take two plates like this also. 1853.5 means it is the area of rolled area. 1853.5 is rolled area and its height is 2000. 2000 into 1853.5. 2000 into 1853.5. Two numbers we have to make for rolling. In this plate we will give rolling. In this plate we won't give rolling. It will be a straight piece only. It is also a development. It is also development. It is another one method. So remember, so many types developments we can do for is this job, because according to facilities, and some companies want to have this much of facilities, so you have to do the proper estimation which development will be good for our own company. This is a development. With this development we can make, this is also a development. These two are the development for one job. Which measurement we have to use, which development we have to use. Another development methods are also there. Those methods also can be described in coming episode. Even if you just recognize one thing, when we roll this one from here to here, for this one, its end won't be bent, end won't be rolled, because rolling machine is like this. Most of the rolling machines are like this. One roller will be here, another roller will be here, in between and its top side there will be a roller. This roller will come down and up. Because of this, when it comes down, this plate is getting bent and it is getting rolling. So starting point, when we will be putting this plate on the tangent point of this roller, from here to here it is having a contact rolling facility, which is a rolling force will reach in here. There is no rolling force comes here. Afterwards we will be pulling it from here to there. Sometimes it will have a more length. We will be pulling means we will rotate the rollers, it will move like this and it will go. But this place from here to here, it will have rolling, it will have a curved shape, it will get rolling. But this much of place from here to here, it won't have more rolling, especially when it comes to down, there will be a slight straightness. This much of place from here to here, when it reaches to down, this round portions, slight radius type portion will touch in this area in some places only. Those places it will have rolling. Other places, especially from here to here, it won't have rolling. It will be a straight portion only from here to here. So we have to bend it before keeping it inside of rolling machine. Bending machine, you know about bending machine. For bending we have to have one punch and one V block also has to have. This in between, this type of plate we will keep. When we keep, there is no need for us to bend it to the end of the V block's bottom side. Slight bending we can give. Again we have to pull it. Again we have to give slight bending, and we can check whether it is having radius of outer diameter 600. For checking we have to make one template. Template will have a, we can check it from inside. That is the best way. For checking inside radius we know from 600 we have to decrease 20. From 600 if we decrease 20 we will get 580. In 580 radius we have to make one template. Next time I shall describe about the proper method of making template. With this template we can check whether it is proper, whether it has been rolled or whether it has been bent in proper radius. So when we keep it inside of this bending machine, frequently we have to check whether using template we have to check whether it has reached in the proper radius. If it has reached the proper radius, both ends have to be bend using bending machine. So otherwise this portion approximate 100 mm won't have a bend. In different types of rolling machines are having different types of non-bending area, non-rolling area. Because if some machines will have this roller the distance from this roller to roller will be bigger than another one. Some ones will have distance will be very smaller than whatever I have indicated here. Same way, this roller also will have changes. Some rollers will be small, some rollers may be big ones. Some rolling machines are horizontal rolling machines, some rolling machines are vertical rolling machines. In horizontal rolling machines are also different ways. Some ones will have movements, it will have movements. Some ones movements are in some places we can see movements in this kind of rollers also. Okay, so I have told you one thing only. When you roll, the end portion, approximate 100 mm, approximate. In different rolling machines, sometimes it will be greater than 100. Some other machines, it will be less than 100. Approximate 100 mm won't be bent, won't be rolled. For that purpose, first we have to keep it inside of a bending machine and we have to bend it. Okay. So, but why did I say it? Means if you take this kind of one plate separate, it won't have bending in its both sides. First, we have to put it inside of a bending machine. Afterwards, we have to roll it. So, may I say one idea for removing this bending? We have to avoid this bending. We have to direct roll it. So, I just tell one idea. Take 100 mm extra with this rolling. Actually, we need 1853.5 only. 1853.5 only. From this 1853.5, just add approximate 100 mm. According to your rolling machine, you add the proper measurement. If it is more than 100, 200, you will have to add 200. If there is no need for you to add 100, some machines, if we in some machines 50 mm maybe not get a proper rolling, so you have to add 50 mm only. Now I am telling about 100 mm. Just increase 100 mm here, just increase 100 mm here. From 1853.5, just add 100 mm here, 100 mm here. We can afterwards directly put into a rolling machine, because 100 mm extra, there is no need for us to roll. So we will get this one avoiding bending machine and only using rolling machine. This is called rolling machine and this is called bending machine. Okay. So that is another method. Now I told about the third method. I will be describing about it in next episode. So one development is this kind of one development. Another development is this kind of one development. When these two reaches this oval shaped jobs, one full development has finished. Okay, and the third development now I told, because with this half perimeter we have to increase 100 mm here, 100 mm here. This is a third method. So if we increase 100 mm here, 100 mm here, here also you have to do like this. From this half round, increase 100 mm here, 100 mm here. If we do this kind of one development, increasing 100 plus 100 in this area, we increase 100 mm here, 100 mm here. What will happen? This no need to make 700. From this 700 we can decrease 100 mm here. From here also we can decrease 100 mm. So it means in this development no need to write 700 here. We have to decrease 100 from here. We have to decrease 100 from here. That is the third method. And fourth method is, we can now we used 4 plates to make this oval shaped job. 2 plates are here, 2 plates are here, total 4 plates. We can make it from 2 plates only, because start our point from center of this place and we have to finish it in the center of this 700. It means one job will have half straight portion, and full half round portion, again half full portion. It means one piece starts from here and that piece end here. That piece ends here. This kind of two plates have to be made. Another one starts from here and it reaches the center of this portion. So in this plate, if you make this kind of one development, it will have a radius in this area only. Another half area we shouldn't make rolling. That is also a development. We can draw it in next class. So one development I have told, second method I have told, third development I have told, increasing 100 mm. Fourth development I have told, starting from the center of the 700 mm and ends the center of the 700 mm. And the fifth method now I am saying is start from here. One full straight length has to be there. One full half round length has to be there. Means it has to start from here and it has to end here. These kind of two jobs have to be made. It is also having some facility. So 5 methods I have told. You have to estimate which method our own company has to be used. Next time I will be saying about this 5 methods and its faults also I will say. Goodness also I will say. Some qualities it will have, some faults it will have. With the proper analyzing, we can just take a decision which development we have to use. In that method, if we use, we will have more production. We can do and complete it very easily. It will have more finishing. It won't lose more amount, more money we won't lose. Welding amount we may not lose. Manpower we may not lose. Everything has to be calculated. Afterwards, we have to take the proper estimation of the development. Okay, we can find out the proper development. We can just analyze and take the proper decision for the proper development. Okay, next time I will be saying about this 5 developments, which development we have to use, because I have told about the goodnesses and its faults of this one and this one only. Another developments faults I didn't say. Next time I shall say its faults. It is having some qualities also I will say about it also. Okay, next time we shall meet. Up to that day, you two just think what are the another methods your companies can follow. Okay, thank you very much.